Basically, I said that I'm gonna do this question myself. So that's good. Oh, wait a second. Okay, great. Now, so speaking of, it says that the vehicle has two wheels on one axle. The passenger stands on platform between the wheels. Fine. And the weight of the machine is 600 newtons, and the center mass is 200 millimeter in front axle, as you can see. So, and the radius is 400. Fair enough. And then says the motor is now switched on to provide a horizontal force of 90 at the ground to move the vehicle forward. How far, in which direction must the passenger move? Oh, sorry, I did not even. Alright, sorry. Chalo. Alright, so I was saying, in this question it's saying that basically you have the weight of the machine is 600 newton, as you can see there is the weight, and then you have 200 millimeter in front axle, which is basically from this it is like here, which is 200 millimeter, and the radius of this is 400 millimeter, the radius of the wheel. And then it says the motor is switched on to provide a horizontal force. So we gotta basically do something. So the motor is now switched on to provide a horizontal force at the ground to move the vehicle forward. So basically, the wheel will move this way. That would mean that the force from the motor should push it backwards, right? Like this. And because of friction, then it will move forward. So now we need to basically see where the person should be standing so that it is balanced. Alright, so we don't know the distance of the person from the axle. We want to find this. Alright, so this is the question. Now the thing is, we got to find what forces are acting. So first of all, this force with the axle is obviously this force will try to bend, like move the axle, tilt the axle like this force. So it means that this force is causing a clockwise moment, right? We're going to write here clockwise. And from the pivot, the perpendicular distance of this force is 200 millimeter, as you can see. Now, similarly, this force, which is 90, will also try to basically cause it to go this way, because it is going like this, right? Which means that this force is also clockwise, and the perpendicular distance of this force is this 400 millimeter, which is the length, right? So we got clockwise forces. Now we got to find where this person should stand, because if you look at it, only this person is providing, it's trying to tilt it like this, right? So this person is providing an anti-clockwise force. Okay, so yeah, and that's 600, and we don't know from his center of gravity what is the perpendicular distance, that's x. Okay, so we're going to make the equation. anti-clockwise equals to clockwise. So anti-clockwise is 600 times x equals 2. Alright. So it's okay, I thought the stream was stopped. So it's basically 600 times x, and then you got the next force, which is 600 and clockwise, and that force is sort of 600 times 200 plus 90 times 400. Okay, so that would be the moment. Okay, and now we gotta basically look at this. This is going to be 600x. This is going to be, I think, can you guys please help me find this? 600 into 200 is 1200,000, I think. I really don't know.
For the clockwise, it's 15,000. So big number.
You just find me this. You will just find me this part, please.
It's 156,000.
156,000 Newton millimeter. Okay, so we got this one. Now, as far as I know, right now he's standing, because he says how far he must move, so he must be standing somewhere. The passenger 600 with mass 200 meters, so right now he's standing 200 millimeter from here, right? So now we got to multiply this 600 times 200. Yes, what you get?
120,000.
120,000. Okay, now if you look at this 120,000, if you look at this, we need to add more moment on the anti-clockwise side because we need to balance it, right? So how much do you need? We're going to find the change. 156,000 minus 120,000. What do you get? This is basically the required moment. Yes, please.
36,000.
36,000. So 36,000 clockwise we need. So right now we know that moment is force times distance. So how much more distance we need is 36,000 is the moment, 600 is the force. So I think it would be 60, I believe, right? Can you check, please?
Yes, 60.
60. Now we know that to increase the moment, if you increase the distance, you increase the moment. So it means the person needs to basically stand behind now. Because why this person needs to stand here somewhere? Because if you increase the distance by 60, so that would mean that you increase the anti-clockwise moment as well. That means that he needs to go backwards, I believe, and with this force, right? 60 millimeter. Wait a second. 60 millimeters. Yeah. 60 millimeter. It should be this one, but it says 60 millimeter backwards. Yeah, I'm gonna repeat this again. Okay, so this is just a difficult question. I just want to tell you what's happening in this. Let me draw it neatly so that you guys understand this. So in the first section, he says the weight of the machine is like 600, as you can see right here, and it's 200 millimeter from the axle. Okay, so the perpendicular distance here is 200, and if you notice, I'm just gonna put anti-clockwise forces and clockwise forces. So I'm gonna say this force will try to bend this vehicle like this, whatever this is, like this. Do you agree? So it means that this is going to turn it clockwise. So I'm gonna put clockwise on this one and write it here. So 600 times 200, this is what we need. Okay, this is the weight of the vehicle and its moment. Then when a stationary passenger of 600 stands with the center behind the axle like this, so he's actually providing a force like this, right? So that is anti-clockwise, and the anti-clockwise force got to be 600 times 200 of the passenger as well. Alright, is it clear, Sohail? Right now it is balanced, but then how do I know what?
How do you know that the distance is
It says when a stationary passenger 600 stands with center of gravity 200 behind the axle. You get it? This is the axle, right? So it means the person standing 200 millimeter behind the axle. That's what this means. Understood? I'm sorry, one thing is off. So right now I just missed one thing. It says the motor is now switched on to provide a horizontal force of 90 newtons at the ground to move the vehicle forwards, which means, sorry, the force was this way, not the other way. It was the forward force, 90. And if you notice, from the axle, the perpendicular distance is 400 millimeter. Do you see? And obviously, if you move it forward, like in this direction, because it says moving forward, I took backwards first. So it is going to turn this, because the force is here, so it's trying to turn the vehicle like this. Sorry, like this. So it means this force is causing it to go anti-clockwise as well. So this is anti-clockwise. Now in the anti-clockwise section, we're going to add 90 times 400. Okay. Now we have 156,000 Newton meter on this side and 120,000 Newton meter on that side. To balance it, we need to add the difference of the moment, which is basically, what was that, Diver? Did you calculate it?
The difference was 36,000.
36,000 moment is needed, right? So they say how far in which direction the passengers should move. So we need to add moment to this, or we can reduce the moment from there, right? So we have to do something like that. Now what do you do? The difference of moment that is needed is 36,000 Newton meter. I have to subtract both sides because they should be balanced. Now moment is equal to force times the distance, 36,000, and force is 600, the mass of the passenger, times the distance. So distance comes out to be 60 millimeters. So what I should understand is that because of this person, the anti-clockwise distance, the moment is more, so I can reduce it. If I reduce the distance, then obviously this much moment can be reduced. So I'm going to reduce 60 millimeters, and the way to reduce is that this person should move forward, so the distance is reduced. So it means this should be the answer then. Okay, is it clear, everyone?
Sir, could you please repeat why the direction should be forwards again?
Yes. So basically, when it's moving forward, the person plus the motor, they're providing anti-clockwise moment, and the weight of vehicle, whatever this is providing clockwise moment. So this side you have greater moment, and this side you have less moment. You agree? Now the weight of the where the weight is acting of the vehicle, that would stay the same, but we can move the person backward and forward to increase or decrease the moment. Right now, on the anti-clockwise side, do we need to decrease the moment or increase the moment? What do you say?
Decrease.
Decrease the moment. Now, if you want to decrease the moment, and we have found how to calculate that, would you decrease the distance or increase it from the of the person from the axle? Because moment, yeah, moment and distance proportional. So smaller the distance, smaller the moment, right? So if I want to decrease this distance, which is already 200, by 60, so what will I do? The person has to move forward 60 so that this distance becomes 140. That way you will balance it again. So that's why I said that he would move forward. Is it clear?
Yes.
Okay, good. So you can take a screenshot. This is just a complicated question, I agree. But what can we say? Some people are gonna get distinctions, no? Alright. Now, so today we will start off with center of gravity. Center of gravity is defined as a point where all the weight of a body appears to act. Now, writing this word is very important. You can write seems, but this is highly important. Whereas center of mass is a point where all the mass of a body seem to be concentrated. Alright, so these two, the keyword in this one is seems, so please do remember that. Now, for regular shapes, finding center of gravity is a piece of cake. All you need to do is you need to create, line of symmetries. Line of symmetry is a line that cuts anything into equal halves. So where it cuts, that would be center of gravity. That would mean here is where the weight is going to act. Same goes here and here. Okay. And weight, this point will be center of gravity. And you can cut a circle from the diameter anywhere. And where 2 meets, that's the center of gravity. And for a triangle, you can cut vertices. And where all lines meet, obviously, that's going to be your center of gravity. Now, generally, this is not very important. Neither, like O-levels, we don't need to tell them exactly how to find
So can you just go a little up?
Yes. Neither, like O-levels, we don't need to tell them how we have to find the center of gravity of a irregular shaped object, but we will still learn the concept behind it for a moment, right? So the concept is that for an irregular shape, when you displace something like this, right, you pivot it somewhere, pin it loosely, why does it stay why does it stay stationary? The reason why it stays stationary is because the weight, wherever the weight is, here or here, wherever, I don't know, wherever the weight is, that basically, I'm going to write it here, because weight is acting in the same line of action as of pivot. So which means that the perpendicular distance from weight is 0. But in this one, when you see, if you apply a force, right, so it moves here, which means now this force causes a moment because it is going, it has a perpendicular distance here, and even when you leave it, because the weight would be somewhere here, and the weight now will have a perpendicular distance from the pivot, so that would try to restore it back to its place. Is it clear, everyone? So it is very essential to know where the line of action of pivot is, and that's how you're gonna basically figure out what that distance might be from the line of action there, right? So we're gonna look at it in the next question, which came, I think, quite some time back. Okay, so going to the next thing. So this question is very important, and this basically is dependent on the thing I've told you. So it says a sign outside a shop is suspended from a rusty horizontal hinge at its top end. The sign hangs in equilibrium at an angle of 25 degrees to the vertical shown. The sign in a square side of length 52. Sign is a square, so it's basically like this, and from the front, and it says the sides are 52 and 52, like that, and it has a mass of 36 kg. What is the moment of the weight of the sign about the hinge? Okay, like that. Now first of all, we need to understand that because it is a uniform shape, it would mean that we have to cut it from the center like this and from the center like this. So its center of gravity must be in the middle. So that's where the center of gravity, just like I did it just now. And the weight must be acting vertically downwards. This is the side view they've shown. So we need to locate where the weight is actually acting, because this means that this side that you see right now here, that is to be 52 centimeter as well, because this is square, right? So they haven't shown they've just shown this side from there. So what is 52 half? I think that's 26, right? So that means that from the top end, from here, exactly the middle where the weight will act is downwards, and this distance that we see right now is 26 centimeter. Everybody agrees?
Yeah.
Now please understand this very important thing. Pivot is here, this is 25 degrees, and we need to find the perpendicular distance. We need to find this distance if we want to basically find the moment. This is the question all about. Okay. So if you notice, this makes a triangle like this.
But why is that 25 centimeters?
Why is it 26 centimeters? Because
Yes.
if there was hinge here, if this was the hinge, the weight is acting here, so 52 half would be 26. So this distance should be 26. Do you understand? Okay. So right now we have 26 centimeter on this side. We want to find this d, and this angle is 25. Which trigonometric function would find me d? Anybody has an idea?
Sine.
Sine. Okay. So I can say sine theta is equal to, so sine 25 is equal to perpendicular over hypotenuse. So can you please find this distance? Yes, go on.
So 10.5.
10.9.
10.9 centimeters. To convert it into meters, it will be 0.109 meters. Now, the weight is mg. The mass was 36 times 9.81. Can you please find the weight? Okay, now we got to find the moment, and it's going to be 353.16 times the distance, which is 0.109. Yes, please.
Sir, 67.1.
That's not an answer here. That's not fair.
38.49.
30. This is 38.49. Okay, which is basically 30, almost like 39. So probably the rounding has done something wrong. Is it clear, everyone? Any questions now? Let me know. Okay. All right. Sultanate and Juwairia and who else? Khatija squares. Do you guys understand everything? Okay. Ayan, Hamad, Ryan, Umar. Okay. And what about where is Maham? Maham is here today. Hiba, Maham, Wajiha, Aman, Ahmed, Sahan, Munim. Alright, good. Alright, even if you have a question, please let me know right now so I can explain it again if you do not understand this. So, everything is clear to you? Okay, very good. Now let's go forward. Now, similar question, this one. This is for the card, and because this is the
Sir,
same.
could you please repeat the previous question?
Okay, Sultanates. The whole thing or a part of it?
Sir, last part.
This one.
Yes, sir.
Okay. So, Sultanate, what I did was, if you notice, you do agree that if this is 52, then obviously the weight, where the weight is acting this side, is going to be 26. You agree? Now then what I've done is I've drawn a triangle here because I need this perpendicular distance. Do you understand, Sultanate?
No, sir, I just wanted to ask why did you take the length 26 and not 52?
Okay, alright, now I get your question. So, in reality, this sign was like this. Do you understand? So, if you look at from the front,
Yes, sir.
the sign was like this, and obviously, this side is 52, this side is also 52, right? So, the weight acts from the center of gravity. So, if it's a square, it means I can draw line of symmetries which will be at this center. You agree?
Yes, sir.
So if this is where the hinge was, then I could say that this point, like from this point to this point where the weight is acting, has to be 52 divided by 2, which is 26 centimeter. Do you understand this? So what I'm saying is, from the side view that you see right here, from the side view, the weight must act in the middle. So the middle of this is right here, which is, like I said, this is 26 from the top. Do you understand? Is it clear, Saltanat?
Yes, sir. Understood.
Okay, very good, very good. All right, so I just want to tell you that always take the center of gravity, and I will tell you how in the later questions as well. So this question is very simple. I would like to give you this as homework. You can try this out. If you don't understand this, do let me know. But that's pretty easy. But I want to start from this point, all right, and then we're gonna understand why center of gravity is so important in AS. So when you want to topple something, right? So this is right now in equilibrium, and why it is in equilibrium? Because here there would be the center of gravity where the weight is acting. If the weight stays in this dimension, it means it will just stay there like this. When you push it with a force, and the weight now is like at this point. So let's suppose if this was like A, B, C, D, and now you applied a force here. It means B is now here, C is here, D is here, A is here. So previously the weight was acting on this side, and now it will topple if we push it a bit more, and this goes onto this side, right? So it changes the dimension, which means it will topple on its own. You just need to push it to this point from where it will topple on its own, and now it will fall like this. So A will be here now, B, C and D, like that, right? So basically now the weight will go on this side, and that's why we call it like it's toppled, right? But what we need to understand is that the topple point is the point between the two basically dimensions, this dimension and this dimension. So we need to understand this particular point, right? Now this question is the same thing, okay? Let me show you how. First of all, they say a uniform solid cuboid of concrete is this, and weight of 4000 Newton, rest on a flat surface, as you can see, and they've given the dimensions as well. It says what is the minimum energy required to roll the cuboid 90 degrees to position. So minimum energy would be when you just leave it at topple point, and then it will fall its own, all right? So right now we must understand that the center of gravity would be at the center, obviously, like this, which means it is at a height of, from the ground, it is at a height of 0.60 meter. How do I know this? I just halved off this value. Do you guys agree?
Yeah.
So I'm going to make a 2D drawing of this because 3D makes it more difficult. Yes. Hello. What's up? Yes, yes. Yes, yes. Okay. Bye. So now this is going to be 0.60. Okay. Now, when you bring it to the toppling point, which should be like this, I believe, like this. That's when the weight is going to act at this point, which is 4000, the same. This dimension, like this, was from here, it was 0.50, and from here it was 1.20. Okay, so the distances are same. So this is like 0.50, and this distance is 1.20. All right, like that. Now what happens is, that we gotta find where the new position of center of gravity must be, because you need to, when you topple something, the center of gravity slightly increases. You're doing work against gravity. So let me just show you how. So we're gonna extend this back like this. This is 90 degrees. Can you find me this length, please? Because this is a triangle, right? Can you please find that? Which formula can we use?
Okay.
Hypotenuse, yes. So we're gonna say Pythagoras theorem, 0.50 square plus 1.20 square under root will give us y. Yes, please.
Hmm, 1.3.
1.30 meters. Okay. Now this is the whole distance, but the center of gravity must be the center, which means that the distance from here till here got to be, let's call this x. So x will be 1.30 divided by 2. Yes, what that might be? I think 0.65.
Yeah.
Okay. So previously the center of gravity was at 0.60, and when we pushed it to the toppling point, now it has raised to this. So basically the distance, the change in distance is equal to 0.65 minus 0.60. So you basically raised it by 0.05. Do you guys agree on this?
Repeat it.
So before toppling, the center of gravity from the bottom was 0.60. Okay. When we pushed it, now because of the push at the toppling point, the center of gravity is now at 0.65 Sohail. Okay. Yes, we can hear you. Now it means the distance, the new height, the height is raised by this much meters, 0.05 meters, right? Now we have done some work, obviously, and we got to find, so work against gravity we have done. So work done will be equal to force times the distance. The force was the 4000 Newton force times 0.05. What you get here? So that would be the answer. This is the minimum work you need to do to basically topple it. Please have a look at it and let me know if you understand this.
Then where did you get the force 4000?
It's given in the question, that's the weight. It says its weight is 4000. Alright, so that's irrelevant. The point is that I just wanted to show why toppling increases the height of the center of gravity, and you need to find that change. Do you understand?
Then do we have to move with 0.5 meters?
You have to do what?
Do we have to move it to 0.5 meters?
Yes, obviously. You have to find the change before and after. That would tell you how much work you've done, right? Okay, you get it?
Then I'm confused. Why did you use 0.6 and 0.65?
Because that's where the center of gravity is. So when you do work against gravity, you do it against the weight, and weight, Sohail, is acting from the center, which is this center, right? So if it was here in the start, now when you put it on this position, the center of gravity is at this point, which is 0.65. So it means that you have raised it by 0.05. You get it? So what the lesson in this question is that you always calculate the force of gravity from center of gravity. You do not take it from the bottom or top, wherever. You need to take it from the center of gravity. So similarly, yes, do you understand this, Sohail?
Actually, how did you get 0.65?
So when at toppling point, this is 90 degrees, so I found this whole length. I found this whole length using Pythagoras theorem, then halved it off to get the center. Do you get it? Okay. Now this question is actually very similar to that as well, but now let's have a look and see what we're dealing with. So it says a uniform solid block of 500 Newton, width this and height this, and block rests, and then basically it falls down. It says what is the change of gravitational potential energy. Okay. Now what you guys are basically been doing in O levels is that you take the height where it has fallen and you use MGH. So there is a wrong way that most of the people do, and first I'm going to do that to explain why you should never do that. So just by looking at it, you will see, in fact I'll ask from Sohail. Sohail, what is the height it has fallen?
Sir, the height of cup?
No, the height it has fallen from. Can you guess that?
Yeah, from 0.8.
Yeah, 0.8. So if I want to find gravitational potential energy, which is mgh, what should I do?
Mass times
I have the weight, so mg is 500, and should I multiply what?
No, you don't multiply the gravity, you multiply just the height. Wait, so when you give the
Yeah, so what is the height?
0.8.
0.8. Now what he told me is most of you might be thinking the same, and that's absolutely wrong, because the concept is that you are not supposed to take the weight from the bottom. You have to take it from the center of gravity. So if I do this, I'm gonna get 400 joules, and that's a wrong answer. So what do we do? So first of all, you guys should understand that the center of gravity is here, not here. So it means that right now from the bottom, this height is basically, this height is 0.3 because half of 0.6 plus 0.8, so this height should be 1.1 meters. Do you guys agree? Alright, Sohail?
Yes, sir.
Now when it has fallen down, so the center of gravity is here, which is basically this height, and that's 0.2. Okay. Now please understand this. The change in height is from this point to this point, so we need to find this height, not that height. Now what do we do for this height? So we're gonna subtract this 1.1 minus 0.2. What'd you get? 0.9. So now the right way would be, when you take center of gravity from this the centers, then it's going to be 500 times 0.9, and that is 450 joules. So that is the right answer. Oh my god, what happened? You guys can hear me? Oh no. You guys here?
Yes.
I have no idea what happened. Suddenly the app crashed. Okay, wait a second, please. It's coming up. Alright. So, what I'm saying is that you should always take the weight from the center of gravity. You're not supposed to take it from the height, from the bottom, or anywhere else. Alright, Yaya, do you understand this? And Ayan, Khatijas.
So, what's the difference between right way and the wrong way? Can you explain that?
Yes. When I asked Sohail that how would you approach this question, he said, I'm gonna take the weight and I'm gonna multiply the height, which is this one.
Okay.
Now, why this is wrong? Because if you take this height, it means you're assuming that the center of gravity is here and now it is here. In fact, the center of gravity was basically at the center of this and the center of this. So you're going to take the height from the former center of gravity to the new one, which is 0.9, not 0.8. Do you understand?
Okay, yes, I got it.
Okay, Aman and Javeria, Ali, Sohail, Umar Shahzad. Sohail, do you understand now? Is it clear why center of gravity is so important?
Yes, sir.
Okay, good flow. Okay.
सर एक बार पिछला समझा दे.
Which one? This one?
This one.
Wait. Okay. So this is the same. So we found that this side was actually 1.20. So you got to half it to find the center of gravity right here. Is it clear? Then we found this side. We know it's 1.2. This is like 0.5, and these are 90 degrees. So I had to find the total length of this, and then I had to find the center. So I found the total length to be this using Pythagoras theorem, 1.30. And when I did half of it, I got the center of gravity, which was 0.65. Do you understand this? Because the previous center of gravity was 60, the new was, so I found the difference. I got this difference. And then I used work done, which is force times distance, to find the answer. You get it? Just like this, I have done the same thing in the next one. So I have found the center of gravity in the first diagram, center of gravity in the second diagram. I found the distance between the center of gravities and center of gravity before and after, which came out to be 0.9, and I use work done. So force times distance, I got the answer. Do you understand?
Yes, sir. I just need to see the last one. The values.
Okay, you can have a look. Alright.
So 0.05 again is the distance, right? Which is
Yes, yes. This is the difference of center of gravity before and after, between that, right? Okay. Should I go forward now? Everything is clear?
Yes.
Okay. So obviously this is kind of a difficult thing for you, but obviously when you practice a bit, now your concept should be cleared, that you have to take center of gravity from the center. So moving on, the next part of this topic is the torque of a couple, and torque of a couple is basically two forces which are acting in opposite directions, different line of actions, right? So first of all, they're going to ask you about so they're going to ask you what exactly is the torque of a couple. So if they say, you can say torque of a couple can be determined when two forces, these are the conditions, okay, have the same magnitude, number two, they have opposite directions, number three, must have parallel line of actions, and number four, you're gonna understand that they must act on the same body, like that. So for example, in this one you might see that these two forces have parallel line of actions, they're acting on the same body, they're opposite forces of same magnitude. Alright, so torque of a couple, you can find the value by multiplying one of the forces by the distance between them, which is s, like that. Alright, you just need to remember that. So it's very simple formula. Now, so we need to understand when something is not a torque of a couple. Okay, so it would be, in fact, let me write a note here so you guys remember this formula. One of the forces,
Sir,
yes,
S is the distance between two parallel lines, right?
yes, one of the forces multiplied by the perpendicular distance between two forces. Alright, is it clear? So you can write it down as well. So the question is when it is not a torque of a couple, and it is not torque of a couple when one or more conditions that I've told you, the four, they do not meet. For example, two forces are parallel, but they are acting in the same way, in the same direction, like this. Two forces are like in opposite directions, but not really parallel, like this. It would not be a torque of a couple. And then maybe it's just a possibility that they're like acting, they're equal and opposite, but they do not have a different line of action. So this would not create a torque of a couple. Okay, is it clear? Now, let's go forward. So, for example, in this question, it says two forces of magnitude F act on a disk of diameter S. What is the torque of a couple? Can somebody please tell me this?
C.
Yeah, C, one of the forces and this. So this is pretty easy. Then in this one, it says a rigid circular radius R has a center X. A number of forces equal magnitude F act edge of the disk. All forces are in plane. Which arrangement force produce a total moment of 2 Fr across this. Now, what is r really? R is the radius, which means this is r, this is r, and the distance between these two would be s. So what do you guys think would be the answer then? A, because basically torque of a couple is force times the perpendicular distance between them, but because s is equal to 2r, which is r plus r, so we can substitute it, and then torque will be equal to 2fr. That's fine. So that's pretty simple in that sense. All right, so anybody please tell me which is the couple here? A, very good, very good. Now this question. Okay, so this is a pretty simple question. I don't want to do this. You guys do this please, and discuss if you don't understand this. And also this one is very simple homework. And yeah, now we're moving to the last part.
Wait, sir, could you go back on the last question?
Yes, here. Okay.
How would the torque be about a point?
So about point P, no worries. You just need to find this.
So, sir, in this case, what would the two parallel forces be?
It doesn't really matter, because this and this have a distance between this, and that would cause a torque, right?
So just MP. But then it's like not about the point though, is it?
They just no. Every point in this will actually, any point can be the center. Any point can be like
Oh, okay.
everything
so
will be
the answer
moved.
is NP though.
Yeah, it's just a gimmick. Okay,
Okay,
just to confuse you. All right, nothing else. All right, then going to yeah. So first of all, we're gonna get single pivot questions in this, and single pivot question super easy. That's just O-level stuff. You say the diagram shows a uniform B, and the plank has a total length of this, and the weight is hung at W, some weight, and says what is the value of W. So we got to find that. The weight of the beam is 50 newtons. So according to the center of gravity, it means that at the middle, the weight of the beam would be here at 50 newtons. So if this is 1.3, then obviously the weight has to be at the middle, which is 3/2, which is 1.5 meters. So that means from here it is going to be 1 minus 1.5, 0.5. Now obviously, now that you guys have learned, this force will turn it this way, this force will turn it this way. Okay. So this is anti-clockwise, this is clockwise. So anti-clockwise equals to clockwise. Now it is going to be W times 1.0 equals to 50 times 0.5. What you get? I think 25, right? So that should be the answer. Easy, right? So then this question is a bit trickier than the previous one. I believe I should have done that, but chalo, never mind. I'm going to do this as well. So it says a uniform rod of 200 meter is freely pivoted at this and horizontally. The weight by a 60 Newton weight. Okay. Attached to a string over frictionless pulley. Okay. Where's the rest of the question? That's not fair. I think oh my god. Okay. I probably did not put the whole thing. Basically, they might be asking the weight. So let me write it. What's the weight of rod? Okay, so they might be asking like this basically. So if this is 200, the weight would be acting here, which from this side would be 100, and from the pivot it would be 100 minus 40, so it's going to be 60. Okay, and on this side, because it's being pulled by 60, so it means here there will be 60 Newton of force. So you got to find the perpendicular of this, which is right here. So that's going to be 60 sine of 30. Liva, do you understand why? So about this pivot, this force is causing to go anti-clockwise and this force is causing it to go clockwise. So it's pretty simple now. So clockwise will be W times 60 and anti-clockwise is going to be 60 sine 30 times this distance from the pivot till the force is going to be 200 minus 40 and that's going to be 160. Okay, can you find the weight please? And let me know if you do not understand this. Yes, go on please.
80 newtons.
80 newtons, so that should be the weight and that's simple, right? Anyway, so the next things you got to do this on your own. This is very simple. And
How did you get 60 in the picture?
how did I get 60 in this one? So the weight is going to act from the center, so this distance is 100, right, from this end. So I want to find this distance. If this is total is 100, I got to subtract 40, I'll get 60. Okay, now we are gonna work on, okay, this is also a single pivot question, you got to do this as homework. And now we're gonna move to the double pivot. So in the double pivot, okay, never mind, this is a different question we're gonna do from here. In a double pivot, I just want to write some of the things that you guys need to remember. Okay, first of all, step 1, you always pick one favorite pivot. That you should do. Then step 2, apply principal moments about that pivot. Step 3, apply sum of all forces equals to 0, and that would get you all answers. So these are the 3 steps you got to do. Right now they say that the weight, beam has a weight of 380 and the length is this, and the beam is supported by vertical force B and pivot C is there as well, and it says the beam is in equilibrium. You got to state the principal moments. You already know sum of clockwise moments are equal to sum of anti-clockwise moments about a point. But the real thing is they want us to find by using moments force FB. Okay, they want us to find that. So what you do? So first of all, I gotta fix something. All right, if I pick this pivot as my favorite, I'm gonna forget about the other one. So I'm going to take, I'm just doing it here. Let me do it here. So step 1, picked pivot C. Alright. So step 2, sum of all moments about C. Now, first moment is this one about C, which means this person is going to turn it this way, which is anti-clockwise. And this force is going to turn it this way, which is also anti-clockwise. But this force will turn the whole plank this way, which is clockwise. I'm just ignoring this pivot right now because I picked one of those. Okay. So now I'm going to apply the principal moments. So I'm going to write anti-clockwise equals to clockwise. And for that, you guys should understand that this distance, like you see, 750 to this pivot, this distance got to be like 3.6 minus 2. What you get there? 1.6, right?
Yes, the
So I'm going to write 750 times 1.6 plus the other one is there here, so it is right in the middle, which means this distance got to be 9 divided by 2, which is 4.5. 4.5 minus 2 is 2.5, so I'm going to write 380 times 2.5 equals to, now clockwise, this force. The total distance was 9, so till here the distance was 9 minus 2, that's 7.0 meters. 7.0 minus 2 is going to give me 5, so it means FB times 5 is going to give me the answer. Okay, can you please find FB now?
So will you not count the clockwise motion above C, FC?
Okay, I'll tell you why I have ignored that.
430 by
Sorry?
430.
430 newtons. Alright, so now the question that I think Khadija has asked, why I have ignored this force. I've ignored this force because it does not have perpendicular distance, and that means that it produces no moment. Do you understand, Khatija?
Yes, sir.
Okay. Alright, please write it down. This is very important. And that's how, if they want to find, now in the third step, obviously they would want you to find FC. So now you do sum of all forces, and that would get you FC. So let me tell you. How do you do this? You write upward forces equals to the downward forces. Upward forces are FB plus FC. The downward forces are 380 plus 750. We already have FB, so FC would be 380 plus 750 minus 430. What you get? Yes, sorry? It should be something. 700. 750 plus 380 minus 430. 700. Okay, very good. 700 newtons. So this is how a full question can be handled. Alright? Is it clear, everyone? Okay. Write it down, please. Great going. Okay. So this is the way to handle. Usually two pivot questions are very few, but I don't know which year this is, 19, so it means it might come again. So you should follow this step method, and this will always get you the right answer. Anyway, then the rest of the questions, this one and the previous one, this is also two pivot you can take, but they have asked you to take X, never mind. And this is also the homework. This is a 2 pivot question as well, and that would be it. Okay, so if you have any questions